Hello ladies and gentlemen, how are you doing? Today we're going to see about meta-analysis. Meta-analysis and systematic review is very important. Next to RCT, it is highly acceptable type of analysis. So how to do meta-analysis? We do have various steps when conducting a meta-analysis. We do have some steps, and the first step is writing the research question and a protocol. Before gonna start our meta-analysis, what we have to do is writing the research question, or we have to state clearly our objective or our hypothesis, what we're gonna study in the future by using meta-analysis. After having clearly stated research question, what we're going to do is comprehensive search. We have to search any finding, any evidence that can support our research question. It might be like advanced search, or it might be the search through electronic or non-electronic method, like emails, gray materials from unpublished articles. And also we can find systematically by using electronic type of searching, like a database, especially from PubMed, Medellin, or different type of database. So after searching, what we're gonna do is selection of studies. So we have to select appropriate study that can support our finding, that can support our research question, that can fulfill our interest of topics. So we have to select the appropriate studies accordingly. After all, there is a quality assessment. We have to assess whether that study is just good and included in our meta-analysis review or in our systematic review by using certain criteria, by using certain standard or guideline. You can identify which type of study is appropriate for your meta-analysis. After all, there should have to be data abstraction, or we have to extract our data. The data should have to be extracted by using templates. It might be using Microsoft Word or Excel. We have to extract the component or the outcome of interest we're gonna look in our meta-analysis. After that, finally, what we have to do is data analysis. We can analyze our finding by using a lot of softwares like Stata or comprehensive meta-analysis and different type, RevMan. We have different type of software that can support us to analyze meta-analysis. So, as we've already mentioned, first we have to have our own question, research question, or what we call it objective, what we're gonna study, what we're gonna identify in the future by using our meta-analysis should have to be clearly put in terms of hypothesis, in terms of research question, in terms of title, as just you name it. For example, there is different type of question frame, but for framing an answerable question in meta-analysis, the very appropriate framework is a PICO. PICO is a very appropriate and very interesting. So it is like, we do have around 4 components. The first one is participant, or we call it, there is study participant or respondent, what we're gonna do with them. So after that, we do have intervention. I stand for intervention, P stand for participant. Intervention or exposure. There should have to be a group that is categorized under exposed group or under the case group or under the intervention group. And we do have another group that is comparatory group or control group. Then we do have an outcome. At the last, there is an outcome that we're going to be measured. For example, let me go ahead with this research question. Are neonates delivered by elective cesarean section risky for respiratory morbidity than who delivered by vaginal delivery? This is our research question. So we can clearly state we do have around four components here, as you can see. The neonate is the participant. Neonate is the participant, and elective cesarean section is exposure. And we do have respiratory morbidity as an outcome, and vaginal delivery is in the comparatory group or the control group. Identifying our study. This is the first step when going to search for our study, like identify your study. It might be depend on method, like methodologically we have to plan first which type of method we're going to use for our studies. It might be depend on the like our interest, our topic of interest, so we can identify it. Then after that, list of popular database should have to be planned from where we can access our studies, especially the most frequently used database were PubMed or Medellin, Embase, Cultural Review or Trails Register or Sinhal, or we can use Hinari. Other strategy you may adopt is like gray materials. You can search gray material from library, hand it to hand from your friends, from your colleagues, from personal reference, and also from emails. And you can get this type of documents also from Google Scholars or Scholar Google. How to search for literature? How to search for literature? This should have to be very important, and we do have certain tips and tricks how to search for literature. First, we have to formulate our question appropriately, depending on the PICO style. Like it should have to have participant, intervention, comparatory group, and outcome of interest. If you are searching PubMed, you need to use a mesh word or medical subject heading. We can call it mesh word, or you can look up word in text word like abstract, title, and you can combine one with two using body logic. You can combine different text word or mesh word by Boolean logic. Then after that, set up proper filters. You have to filter by maybe the date of publication, the year of publication, region of publication, method like study design, maybe the filter, what you are going to study should have to be stated clearly like that. For others, you can use text word or abstract and others. Oh, what's Boolean logic? What's Boolean logic? Let we gonna see what's Boolean logic. Boolean logic is it is what we call it like connectors, or you can just use this as something that connect different word together, or two or three or four together. So the first one is ENDA. This ENDA is the zone covering common area between two ellipses. We do have a population A or we do have population B. So what population A and B have in common is called this ellipsis or ENDA. So ENDA is where the intersection of between two different terms or different statements. Boolean logic second is or. Or is either one or either. You can completely take population A or this part, or you can completely take this one. That means this part can replace completely this one. So you can select either this one or either that one. It is covering the two lapses. Let we start. Sir, research issue. Let's say we want to know whether elective cesarean section is a risk for occurrence of neonatal respiratory morbidity. How should we set up a search strategy? We will search PubMed for as an example. Okay, here is the search. First, we do have word. This word is called maybe mesh word or text word. And the syntax indicated that there is a word that can replace others, especially if we use or. We are replacing one with another. If one option fails, we can use another option. For example, respiratory distress can be replaced by respiratory distress syndrome, or we can replace by using respiratory distress syndrome in newborn, or you can use transient tachypnea of the newborn, or persistent pulmonary hypertension, or persistent fetal circulation syndrome. This can be used. Then after that, we have to connect it because our topic of interest is cesarean section, whether cesarean section can cause or can affect respiratory distress or not. So, the study should have to be connected by using ENDA after stating respiratory distress or respiratory distress syndrome. Then we use ENDA as a boolean, logic boolean. After that, the next text is cesarean section, or there is another word that can replace cesarean section. It is abdominal delivery, or we can say cesarean delivery also. This is how to search. It do have its own topic, so we're gonna see it in different topic. Keep some and throw out others. After searching, we may get a lot of plenty of articles or from different journals. So what we're gonna do here is identifying which type of article is very important for us. So we have to keep some and throw out others. There should have to be some articles that gonna be discarded. We cannot include all studies because of cost, because of time, because of relevancy of that study, and also because of our topic of interest. Then we have to keep the one we want, depending on the level of evidence and quality, whether it's a good quality, by checking using GBI, or GBI means Journal Briggs Institute guidelines or checklist or criteria. Once a quality score is assigned using GBI, impact of excluding low quality study can be assessed by sensitivity analysis. Like case series, case report can be discarded, and selection problem are a major problem, during meta-analysis. This is a GBI criteria for cross-sectional study, and we have to have plan or action plan. Action plan do have some set of steps. There are study eligible for meta-analysis. The step one, if yes, we can go ahead. If no, that means if they are not eligible, we can discard it here. If yes, what we're gonna see is abstracting the data. Abstracting the data. After abstracting the data, we have to enter a specified into the specified formats by data extraction template. After that, there should have to be analysis. How to abstract data, or how we can extract our data from the article. The first one is create spreadsheets from Excel, from Microsoft Word, or from different Microsoft Office. For each study, we have to create columns, especially name of the study, or the title of the study, or we can use ID numbers. Then after name of the author have to be put in the second column with a year of publication. Number of participants who received intervention or exposure. Number of participants who were in a control arm. Number who developed outcome intervention. Number of who developed outcome in control arm. Let me see in our cases. We got like 70 studies to do our meta-analysis. Here is our template. We do have some column, number of study, or this is identification of our study. Then we do have author, the name of the author, and the year of publication. Here is cesarean section with respiratory morbidity. This is those who develop the intervention, who develop, among the intervention, who develop our interest, that is respiratory morbidity. Total cesarean section, we do have total cesarean section. Vaginal delivery with respiratory morbidity, and this is the total vaginal delivery. So year of publication, this is event in exposure, total cesarean section, event in control population. Then analyze data statistically. We can combine data to arrive at the summary by using three method or technique. The first one is effect size. The effect size can be used odds ratio or risk ratio or hazard ratio for the final summary or for the final presentation. The other one is variance with the 95 confidence of interval can be identified. Then test of heterogeneity should have to be statistically done. You know, here on the effect size, standard, mean difference, variance, and others can be used. We do have two graphs, forest plot and funnel plot or publication bias. So this graph can be interpreted accordingly, and we have to examine why the study are heterogeneous, if they are heterogeneous, by using statistical package or several we have several so let me see effect size. Effect size is a value which reflects the magnitude of the treatment, or more generally the strength of relationship between two variables. It can be identified in terms of odds ratio, relative risk, or hazard ratio, difference mean, and difference. The unit of currency in a meta-analysis. If there is no effect size in meta-analysis, we cannot accept that meta-analysis as highly evidenced meta-analysis. Different meta-analysis may use different size. It depends on our interest. Here is the heterogeneity. Heterogeneity refers to any kind of variation across study. That means we do have a lot of study, and how do that study heterogeneous? How do they differ from each other? We do have one and two. Here we do have two example apples. Then when we just connected or we just combine these two apples, it may have some difference. Cannot be like an original apple. So this is called heterogeneity. It can be identified through clinical, methodological, statistical, and others. Clinically, we can identify the population might be different through age or sex or setting, especially geographical location and primary, secondary care. Methodologically, we can say study design, especially RCT, cohort, others. They are different from each other methodologically. The other one is outcome. It might be identified like by mean difference, odds ratio, hazard ratio. So this can make different study like heterogeneous. Statistically, there is test we are going to use the other one is chi-test or I-square, or we can stratify by subgroup. There is stratification. Ways of assessing heterogeneity. Visually inspect the forest plot. Visually we can see overlap between confidence of interval. If a lot of study have overlapping confidence of interval, we can say they are homogeneous. And also statistically, we can see the chi-statics or chi-square test or test for overall homogeneity, like um, statics based on summation of steady weight, individual steady weight in brackets. We do have steady effect size, individual steady effect size might be odds ratio, relative risk, or hazard ratio minus we have a summary effect. We have a summary effect, and we can square it. So this is how we identify whether it is homogeneous or not. Ways of assessing heterogeneity, chi-square test. The power of the test is low for few study and fail to detect heterogeneity often because chi-square only indicates the association. We cannot identify the direction of that association, whether it's protective or a cause for outcome. The power is too high for meta-analysis with much studies, so we have to use like q minus degree of freedom. We do have our own formula in our here as indicated. So minus degree of freedom, if it is less than 0, less than and equals to 0, it indicates there is homogeneity. If it is greater than 0, it indicates heterogeneity, or small p-value can indicate heterogeneity, like p less than 0.05. The other one is by using I-square. I-square statics is calculates the proportional variation due to heterogeneity rather than due to chance. The chance is excluded by using the statics. Percentage of variation due to heterogeneity versus chance can be calculated like this. So q minus degree of freedom over q times 100 as a rough. If it is less than 0.25, there's low heterogeneity. That means it's almost homogeneous. If it is equals to 0.50, it is moderate heterogeneous, and greater than 0.75 indicate that it's highly heterogeneous. For example, this is our study. As you have indicated here, study subgroup, here is the name, and event total, vaginal delivery event total weight. We do have risk ratio. The final effect is 2.24. 2.24. Here is the 2.24. This is what we are going to present or what we are going to interpret. Here, heterogeneity is 0.19. By using chi-square is 168. Degree of freedom 60. P is less than or equal to 0.001. And by using percentage, it is around 91%. So it is heterogeneous. It is heterogeneous. Overall, that effect 6.53, and it is heterogeneous. Summary estimate for respiratory morbidity study. I'm sorry. The pooled risk ratio shows that the risk of respiratory morbidity in neonates delivered by elective cesarean section was increased by 124% relative to neonates those delivered by vaginal delivery. As you have seen here, we do have 2.24, so we can just change this into percent, or we can just report by using 2.24 as it is. This is effect size. It is presented by relative risk. So 95 confidence of interval is 1.79 to 0.68. Here it is. All right. 1.76 to 0.86 to 0.86. That in 95 out of 100 such meta-analysis, the polarity risk ratio would lie between 1.79 and 2.68, indicating statistically it is significant because 2.24 is found between these two intervals. 1.79 is less than 2.24, 2.24 is less than 2.68. So this indicates that it is significantly associated. Test of heterogeneity, I square is equals to 91%, chi-square 168, this is greater than 0, p-value is less than 0.05. That this study were heterogeneous. It indicates that the study is heterogeneous. This is a forest plot for our meta-analysis as you've indicated here. This is a forest plot. The dotted line passes across null or 1.0 here. We do have 1. It is right at the right side of the 1. The risk estimate of each series lined up on each side of the dotted line with 95 confidence of interval spread as the lines. The diamond shape indicates the summary effect or our relative risk. Here is the confidence of interval. The two end of diamond indicate 95 confidence of interval. Here 95 interval confidences. The size of the black square box indicate weight of the study. Weight of the study. The size of black box is indicating the weight of the study. Very interesting. So they call it a forest plot that you don't miss the wood for the trees. And this is all about today. We're gonna start our next from publication bias. And have a good day. Bye bye.